Okay, I want you to imagine something. Picture the electricity in your brain. Not just flickering, but erupting. In a split second, it becomes a full-blown lightning storm, just trapped right there inside your skull. So what happens when a storm like that is finally unleashed? Let's find out. And look, we're not talking about some tiny little surge here. This is an electrical event that's 100 times, 100 times the normal level. That is the kind of catastrophic failure we are about to dive right into.
So what happens to you in the next 5 seconds? What's really at stake? Because the clock is ticking, and your brain, it's fighting for its life. And that sense of you, everything you know, it's about to be totally and completely overwhelmed.
All right, let's get into it. The first second, overload. We're going to break this whole thing down second by painful second. And trust me, this first one, it's not a gentle slope. It is an immediate, total system collapse. We're talking senses, motor control, the whole shebang.
So just look at this contrast. On one side, you've got your normal brain activity, right? It's like a finely tuned orchestra, all these precise electrical pulses. But on the other side, this massive surge. It's called a hypersynchronous discharge, which is a fancy way of saying millions of your neurons are all screaming at the exact same time. It's not a symphony, it's just pure, chaotic electrical noise.
Okay, this timeline is basically our roadmap through the chaos. And just look how fast this all goes down. At just 1/10 of a second, your senses literally implode. Your vision just bursts into these chaotic flashes of light. There's a metallic roar that fills your ears, and if you even try to form a thought, forget it. It's just drowned out by static.
And by the half-second mark, your muscles just lock up. The motor cortex is completely swamped. Every single muscle goes rigid. And the terrifying part? You're still technically conscious. You're aware of what's happening, but you are completely powerless, just trapped inside what feels like a computer that's crashing in real time. So now, we're moving into the next phase. Consciousness itself collapses. This electrical storm is it's relentless. It's so intense that your higher brain functions, the things that make you, they just start to shut down.
Right at the 1 second mark, the overload triggers what's called a tonic-clonic seizure. This is a massive event. The body convulses because neurons are just firing off totally at random. Inside your head, your brain is burning through fuel, oxygen, glucose, at a rate that is it's impossible. It's pushing itself so far beyond what it was ever designed to do.
And you can see the sequence of failure right here. The systems are just going down one by one. First to go is your prefrontal cortex. That's your logic, your personality, poof, offline. Then the hippocampus, your memory center. That follows right after. And the final domino to fall, the thalamus, which is basically the brain's central relay station.
Yeah, and by the 3rd second, that failure of the thalamus is the final blow. It's the knockout punch to your consciousness. It just can't filter that insane flood of signals anymore. And without that filter, your sense of self, it just evaporates. It's exactly like a blown fuse in the main circuit of your mind. You aren't just knocked out, you are completely gone.
Okay, so far we've been talking about the experience, right? But now the brain begins to break. And I mean physically break. We're shifting from the overload to the actual microscopic damage that's happening. The brain isn't just glitching out, it is actively breaking down cell by cell. At this point, the electricity itself actually becomes toxic. There's a name for this process, excitotoxicity. It's a deadly chain reaction where neurons are being stimulated so hard, so intensely, that they're literally excited to death. So, how does a neuron actually die in this situation? Let's walk through it. First, that continuous firing just overwhelms it. This allows a massive flood of calcium to pour into the cell, and the neuron just can't handle it. It swells up, its internal structures fail, and then it breaks down and dies. And for some of these cells, there's no coming back. The damage is permanent. And then, by the 5th second, the main event is over. The brain is basically a short-circuited circuit board. What's left is this chaotic mess of impulses. Your awareness, your memory, any kind of voluntary movement, it's all gone. The damage is literally etched into its pathways. Now we're looking at life after the storm. I mean, what happens when that electrical surge finally stops? The storm might be over, but the wreckage is still there. So let's look at the slow, really painful process of trying to reboot a system that's been this badly damaged. So, in the immediate aftermath, when consciousness finally starts to creep back in, it's a world of pure confusion and pain. You have no idea where you are or what just happened. Your senses are hypersensitive, lights are way too bright, sounds are painfully sharp. On top of that, your muscles ache from the seizure, your speech is slurred, and you're left with this absolutely crushing headache. It's the price your brain pays for the chaos it just went through.
And these aren't just short-term problems. The effects don't just vanish. That cellular damage can leave behind some serious long-term scars. We're talking persistent memory gaps, real difficulty focusing, emotional instability. I mean, for days, weeks, maybe even longer, you could struggle with all this. An event like this fundamentally changes the entire landscape of your brain.
Which really leaves us with this one powerful thought. 5 seconds sounds so short, right? But inside the brain, 5 seconds of electrical overload it's a lifetime. It's a lifetime of trauma, a lifetime of damage. And it's just a stark reminder of how incredibly delicate that electrical balance is, the very balance that creates everything we think of as us.